Hi Year 12 and welcome to a series of 4 videos for the topic Further Differentiation for the Advanced Mathematics course. In this first video we're going to look at the derivatives of trig functions. Now before we get started we need to establish an important limit, and that is the limit as x approaches 0 of sine x divided by x is equal to 1. We can actually see this from the graph. So have a look here. This red curve is the sine curve, and the blue line is the line y equals x. What happens as we get closer and closer to 0? Can you see that the two curves approach one another? They become almost the same thing. What happens when we divide something by itself? We get 1. So as we get closer and closer to 0, sine x and x approach the same value. So when we divide sine x by x, we get 1. So here we go. The derivative of sine x is cos x. So you probably want to write that down. Now I'm going to go through the proof. It does involve some mathematics that is beyond the advanced course. Extension 1 students, you should be able to follow this, but if you're an advanced student, you might want to skip over this part. We are going to start, as always, with first principles. F dashed of x is equal to the limit as h approaches 0 of f of x plus h, take away f of x all over h. And here's my function. F of x is equal to sine x. So I'm going to substitute x plus h in here, and then x, and then divide by h, like this. Now here's the extension 1 part. We need to be able to expand this. So hopefully you remember that this is sine x cos h plus cos x sine h. So I've expanded that out. Now I'm going to factorize it. Here I can see a common factor of sine x in this term and this one here. So let's do that. I've got sine x outside of cos h, take away 1, and then the sine h cos x goes here. Right, now I'm going to split it into two limits. I'm going to have the limit as h approaches 0 of this part plus the limit as h approaches 0 of this part. And I've done a curious thing. Have a look. See this sine x and this cos x? They don't have anything to do with h. So they're not really part of this limit. I'm going to take it out the front. Same here. Now what did we learn about this? The limit as h approaches 0 of sine h over h is 1. So all we've got to do is try and figure out what this part is. So what is the limit as h approaches 0 of cos h take away 1 on h? So here on Desmos, I've plotted it. And we're going to have a look what happens as this point gets closer and closer and closer through to 0. See whether we can figure out what the limit is. Of course, if we substitute the 0, and we're going to get a number divided by 0, so it's not going to be defined at that point. But what is it approaching? So let's have a look. You can see that point changing as I'm getting closer and closer on either side, and then right in the middle there, it's undefined. So it's actually approaching 0. You can see how that curve is continuous except for that point x equals 0 or h equals 0. So this limit here is 0, which of course is going to wipe that part out, and so f dashed of x is equal to cos x, and so we've proved it. Now it's all very nice being able to prove something, but how do we actually use it? Let's have a look at an example. Find the derivative of 2 sine 3x plus 5x. A couple of things we need to remember here. Firstly, when we're differentiating, we differentiate term by term. Secondly, when there's a 2 in front of a function, it's going to hang around. Thirdly, this is a chain rule. Can you see that? It has a function inside another function. So let's have a look at the derivative and we'll work out how we got it. So the 2 hangs around. The outside function here is a trig function. The derivative of sine is cos. We're not going to change this inside function. So derivative of sine 3x is cos 3x, multiplied by the derivative of the inside function, which is 3, plus, now derivative of 5x is 5. And all I have to do is tidy this up. I'm going to bring this 3 out the front to join with that 2. So our answer is 6 cos 3x plus 5. Let's move on to the derivative of cos x. Now, advanced students, you should be able to follow this proof. By rewriting y equals cos x as y equals sine of 90 minus x, find its derivative. Now, why can we do that? Do you remember? Because cos and sine are complementary ratios. So that means that cos x is equal to sine of 90 minus x. All right, so y equals cos x. Let's rewrite it. Now let's do the derivative. This is a chain rule again. Here we go. Sine of 90 minus x is going to become cos of 90 minus x, and we're going to multiply by the derivative of the inner function, which is negative 1. Bring our negative 1 out the front, and cos of 90 minus x is sine x. So the derivative of cos x is negative sine x. Here's an example. Find the derivative of f of x is equal to 2 sine x, take away cos 4x. So again, we're going to go term by term. The 2 is going to hang around, and here we have a chain rule. Let's have a look at it. So f dashed of x. Sine x becomes cos x minus cos 4x. The outer function there is cos, so that's going to become negative sine 4x. Multiply by the derivative of the inner function, which is 4. And we just need to tidy that up. We get 2 cos x plus 4 sine 4x. And finally, tan x. How might we find the derivative of y equals tan x? What's the relationship between tan x, sine x, and cos x? Do you remember? Instead of writing tan x, we can write sine x over cos x. So to differentiate that, we're going to use the quotient rule. So u is going to equal sine x, and v is going to equal cos x. U dashed is cos x, and v dashed is negative sine x. Now we just need to substitute into the quotient rule. So we're going to do v multiplied by u dashed, take away u multiplied by v dashed, all over v squared. So substituting it in, we get this. Okay, we're going to tidy this up. This is cos squared x plus sine squared x all over cos squared x. Now what's this identity? Cos squared x plus sine squared x is 1. So the derivative of tan x is 1 over cos squared x, but more often we will say that it is sec squared x. So in summary, the derivative of sine x is cos x, the derivative of cos x is negative sine x, and the derivative of tan x is sec squared x. Let's finish off with some examples. Find the derivative of y equals cos x plus tan x plus 5e to the x. So we've got a mixture of functions here. We're going to go term by term. The derivative of cos x is negative sine x. The derivative of tan x is sec squared x. And what's the derivative of 5e to the x? Remember, e to the x, the derivative is e to the x. And this 5 out the front is just going to hang around. So dy dx is negative sine x plus sec squared x plus 5e to the x. About this one, f of x is equal to cos x plus 1 in brackets to the power of 5. We have a chain rule here. Our outer function is a power rule, and inside we've got some trig and another power rule. Right, let's do the outer function first. The 5 comes down, leave this alone to the power of 4. Then we're going to multiply by the derivative of the inner function. Derivative of cos x is negative sine x. Derivative of 1 is 0. I just need to tidy this up. I'm going to bring this negative sine x out the front. So our answer is negative 5 sine x, and then in brackets cos x plus 1 all to the power of 4. And last one, the derivative of cosec x. Remember, cosec x is 1 over sine x. Now we could do this as a quotient rule. It's a bit of overkill, or we could lift it up the top like this and do a chain rule. So 1 over sine x is the same as sine x all to the power of negative 1. So outside function is power rule, inside function is trig. So we're going to do the negative 1 comes down, sine x to the power of negative 2, multiplied by the derivative of the inside function, which is cos x. Hopefully that makes sense to you. Let's drop this down to the denominator. We end up with negative cos x on sine squared x. You can see how I didn't move this negative 2 in there. Because particularly if I put this -1 in there, that actually means something different than to the power of -1. It means inverse sine. So keep it in brackets when it's a negative power like this, but when it became positive here, I was able to write it as sine squared x. Now we could leave our answer like that, or we could say, well, cos over sine is cot, and the other 1 over sine is cosec x, but you do have the marks at this point. That is fully correct. Okay, that's it for this lesson. In our next lesson, we're going to look at the derivative of log functions.